So chi-squared goodness of fit can be used with biology scenarios. So let's consider this. Genetic eye color. We have a study that looks behind the genetics of eye color. And in humans, brown eyes dominate blue eyes. I have a study of 100 couples where all couples in the study are both believed to be heterozygous. So big B, little b. Each couple had a single baby and 15 of them had blue eyes. And at the 5% level, significance, determine if the parents were all heterozygous. Well, we're going to do a hypothesis test. We are going to do a chi-squared goodness of fit test. And so if I think about what I'm going to try and do, I'm going to try and look and see my null hypothesis. My null hypothesis says all couples are heterozygous as it fits the proportion of blue eyes, whereas the alternative is are not heterozygous, meaning that it does not fit the blue eyes. Well, let's think about what is the proportion of blue eyes going to be. Well, one parent gives a big blue and a big B and a little b because they're heterozygous, and the other gives a big B and a little b as well because they're heterozygous. So the possibilities are big B, big B, big B, little b, big B, little b, or little b, little b. And these all have equal chances. And so this is 1 in 4, this is a 1 in 4, this is a 1 in 4, this is a 1 in 4, and this is a 1 in 4 chances. These people here are all brown eyes. And so if I'm actually going to look at the observed and the expected for blue eyes or brown eyes, my observed is there was 15 babies with blue, and so there were 85 with brown because we were looking at a total of 100 couples. The expected value, well, if there's 100 couples, 25% of them, because it's 1/4 of the total, it should be blue, and so hence 75 should be brown. And so I'm going to do the chi-squared goodness of fit test with degrees of freedom. Well, it's going to be 2 minus 1 times 2 minus 1, so there's 2 rows. Sorry, that's not right. That's independence. Degrees of freedoms will be number of categories minus 1. Well, there's blue and brown, so there's 2 categories. I'm going to subtract 1, so degrees of freedom of 1. And so let's go to my calculator. I'll put into my statistics. I know that this is going to be 15 and 85. And the expected is going to be 25 and 75. Enter. And so now if I can go over to my stat, I'm going to do my test, my goodness of fit test. I have it in L1 and I have it in L2, but my degrees of freedom now is 1, and I'm going to calculate it. And so my chi-squared is equal to 5.33, and my p-value is equal to 0.0209. My alpha level is 0.5, so based upon my p-value, I am going to say that I'm going to reject the null hypothesis. Therefore, I'm going to reject the null hypothesis as the p-value is less than alpha and say strong evidence that the couples were not heterozygous. Okay, I don't know how to spell that word very well, so I'll scribble it out at the end. And so basically what we're saying, because these values are not close enough to be just random variation, we're going to say that these couples, not all of these couples were heterozygous. We had some that must have been, I think it's homozygous is the term that they're looking for.